odor localization system for gas leak detection. Mainly some part of my PPT for today is take from this book, I mean the odor localization system. About the agenda of this talk, first we will talk about ODLS or odor localization system or food tracking system, which we will talk that why we have this specific topic. Then later we will talk about ENOS as the initial stage of the ODLS system. We will talk about plume tracking and odor tracking difference. Current odor localization system we will talk. Then we talk about the platform that I designed some years back. We call it Mufta. And then we have one conclusion. And finally, we will discuss about the reference that I cover in this talk. Am I audible there, Zuyan? Everything is okay?
Yes, from my side,
Okay,
it's okay. Yeah.
Okay, very good. First of all, let us see what is ODLS, or as the short form of odor localization system, and why and what we should have. Odor tracking activity is one of the critical activity that from long back people have done. If you see the cartoons or some movies, there is some boy like this that having the canary or any birds in the cage. And then when something happened in the mine, that canary die. It means that there is the leak for the CH4, some gas or CO2 in the mine. And then all the people should leave the mine and save their life. It can be one history or one evidence for using the odor tracking system, or in the even nowadays when we have the fire in any building, there is some chance for the blast due to the gas leak in the building, which always all the firemen are interfere with that. Means that when they are going to um, work on the fire, one of the another tragedy that most of the time we have in the fireplace is the leak of the gas, which nowadays we have. Then also it could be some other application. For example, if you see in the airport or in the any public place, there is some dog that they are searching for between the luggage and so on. They are searching for the bomb. They are searching for the some drug and so on, which all of them show us how this topic can be hot and how people are working nowadays for that. This story that I tell you from different place make the scientists in the world to find to have some solution to finding the different resource of the gas. But we have something that before study the ODLS, we should think about it and also study that part as the initial gate for this knowledge. You know that in human, we have one sense that we know it of sense of smell, and which come through the olfactory system. This sense is something that we can detect and distinguish between the different odor. For example, if you know CH4 itself, it don't have any smell, and they will put some additive smell into the ref that people can understand the leak. And unfortunately, most of the death which we have through the CH4, it's because of they cannot smell it. Otherwise, they will wake up and then they can discharge from the room. Then this smell sense in the nature also, it's very famous and it's worked with different creatures. For example, African elephants, they have 1,948 organ to smell it and use their smell sense. Rats they have 1,207, or cows, for example, they have 1,186, or some turtles, they have 1,137, and dog even have 811. Maybe it's interesting for you to know that this smell, it has some percentage with the weight of the brain. For example, for the mouse, this is 2% of the weight of the brain of the mouse. For the dog, this is 0.31%. For human, is 0.01. This is the olfactory bulb, or the place that human or other creature they can sense the smell. And from this graph, we can understand that from the human, we don't have very good smell detection system, or even we can say that we are weak. If compare with the other creature, even you will see here that if it will be the human smell, deer, they have 9 times better than human. Dogs are 20 times better. Elk are 1,000 times, and bear are 2,100 times better than human. Then maybe it will be the good hint for us, and review that story of the canary boy or dog in the airport, and why we are
On
using the
computer
dog,
science too?
Yeah, I'm computer
or
science.
dog or cannery inside the mine and inside the airport. It means that we know that human smell and human olfactory system is not that much strong that can sense the all the odors and work even properly compared to other creatures. Even as I compare for the between the dogs and for the uh, human, we will see that we have 300 millions of the olfactory receptor for the dog, and for the human, we just have 6 millions of the receptor, which all of us encourage the researcher to think about that, how we can rectify this problem for the human, and how we can give the sense better. Even maybe it will be interesting for you that even there is one type of the fish that can smell better than human and can use this olfactory system better than us. Then all of them are the hints and start for the doing the job that the other localization system or smell system for human and creation. If we look to the nature, we can see that there are some creature or very nicely can do this job due to their nature. For example, if you see there is one type of the moth or honeybees or rats that they can localize and finding the food and detect the predator or find the mates for themselves with the help of this other localizing. And for human, as I already tell you, they can find and localize the hazardous material and leaks, chemical hazardous source and location, bomb detection, mine detection, and so on. It could be the application for them. But it could be one question that, okay, if the creature are that much good, we can use them and no need to have any other system. But there is some problem for that. One is the long time to train. For example, if the dog, which we have in the airport, first of all, it will take some years for them to train them. Another thing is that they are always in the program, prone of the fat, and also efficiency of them. After some year, it will come down. For example, the dogs which they are using in the airport, they can work maximum for 2 or 3 years. After that, they will not be that much sensitive. And also, in the dangerous area also, because the life of the creature is also important. From the ethical point of view, it's not good for us to just use them. Then the application of the odor tracking system and the system which we have used, all of them engage the mind of the researcher to think about this system and having the system such a way that can help the human to rectify the problem of the smelling. Here I categorize the odor localization and plume tracking activity between the nature, the natural and artificial one, which for the natural one, we are using the creature, something uh, with the aim of finding the foods, mates, etc. Especially, for example, beetles are very good to finding the food with the help of the odor localization. There is some nice research which scientists they have done and finding the algorithm of the movement of them. Or moths is one of them which have the pheromone, and based on this pheromone, it can find the mates very nicely. The algorithm of that also recorded with the moths algorithm, which later we will talk about. And also we have some animals which can use by the human, as I tell you, for example, dogs and also birds, especially dogs, for example, when we have the earthquake, when we have the avalanche, when we have the mines, they can come and aid the people to work. As the artificial work, we have some work to finding the source of the CH4, C2, and N2 to protect the environment, or also some biogas, some methane, some H2S, and so on. These are the application which mainly they are using some stationary sensor of array, and they can find the source, or they can detect the level of any of these hazardous gas for us. So on with the artificial application, we can have the security of the detecting, as I again repeated here, for drugs, prohibited drugs, for avalanche body, for toxic waste, and hazardous gas leaks, which mainly now we try to use them with the help of the robots. Means from the root of the application and use of the odor tracking and plume tracking, our aim is that doing the artificial job for security and detecting with the help of the robots. Then application now is become clear for us. But why robots should use? Because you know that as the very common introduction about the robots, robot can deploy quickly and maintenance with the low cost, no need for training, which we had, for example, for the dogs and birds and so on. Workload of them, there is no issue for that. They can work for the long time. And also they can enter to some dangerous area. For example, think about some radioactive area, think about some nuclear jobs that these robots can go, and also some place that maybe they think that there is the bomb there. Then if you enter the human or enter the dogs, then if the bomb activated that time, then it's not good from the ethical point of view. Then which type of robots can help for us? We can have three type of the robots, some waterborne one, airborne one, and terrestrial one, which mainly this terrestrial one will use. And what nowadays we have the application and usage of these robots in the form of single form, or we have them in the swarm. We have more than one which they can go and localize the source in different place and then come back and give us the reports. Then the next stage, which now we are in that, it's the stage number 3, which we are using more than one robots. Maybe it will be in your mind that, okay, we understand the application and we know that we should use the robots. Okay, but what should be the structure of these robots? This robot should have sensor array. It should have some controller, some place that they can log the data, some parts that they should classify the data. Why? Because, for example, we want to find out the different gas. Then you should sense and detect and also classify the sensor response for us, then this data classification will come. Then after this classification, somehow you want to make the distinguish between the CH4 and C2 and find the rate between them. Then you need to know the pattern of this gas. Then pattern recognition will come to picture. And next stage is that, which is more valuable. You want to predict the movement of the gas, which it will be a very difficult job. Still, nowadays, so many people are working on this area. I will show you even in my work how we work for the next stage and prediction of the spreading the gas. And then you should have some part which related to the movement of your. It's obvious that you should have some communication and even you should have some path monitoring or some map for the movement of your robots, and which you can find and show the source and source of the gas and the place that you start, something like the graph that I show in this. Okay, then in all, if we should go more detail inside the robots part, for the tracking the gas or tracking the odor, we should have some sensor array which we can take the signal, and these signal are in the form of the analog, then we should convert it to the digital, then some data logger and pre-processing job we need here, and some sensor array which work as the feedback for us. Like this loop, we can acquiring the robot, the order. Then after that, after taking the data from first box, we should classify and find the pattern of my order. Then I need the data classification and pattern recognition part. And as the next part, I need some prediction part, which should give me the decision command to my robots to move towards the source. Because if I can detect the gas and not going through the source of the gas, then it will not be the good approach for my robots. Then finally, the robot movement will come to picture. Then, if you can see this box, we have two parts. One is that odor acquisition system or odor acquiring. And another one is that odor detection, which I will find, okay, the gas is CH4, the gas is ethane, methane, propanol, ethanol, and so on. And the next part can be the tracking system, which force my robots to go and to go through the direction of the gas. This part means that tracking system is one of the most important and we can say difficult part in designing the robot. So on, whatever data that I have, it can use with some communication system and send it to one mainframe. And from that, I can analyze, I can even somehow give the command to my robots and do some primary analysis or even final analysis to give the robot path and also specify its movement. All these things that I told you, we can call it as the odor localization or odor tracking system. If I could reach the source of my odor, I'm odor localizer. If I could track it, I'm odor tracker. Means because due to the movement of the molecule of the gas, which they are working very funny, very dynamic, and small change can a small change in the environment due to the wind, due to the temperature, due to the humidity, it can change the movement and form and shape of the molecule for us. Then localize tracking the source, maybe it's not very easy job and always it has lots of problems. We will see this graph at the time that when I will show you my prototype robots, which I designed it some years back, and we will talk more about this part. Okay, I talk about the first part, which that was sensor array position. What nowadays come to picture about the sensor part is that they thought that instead of having the one sensor, we can have array of sensors. Means that I can have combination of different sensors. What is the use of that? The use is that, for example, I have one sensor which is sensitive to gas number A. Second one, it's sensitive to A, but it's more sensitive to sensor number B. And also I have the same scenario for gas C, D, E, F. Then I can have the different gas in one chamber and then detect the data. Through this detection, I can take and extract the pattern from my odor, and then I can detect the gas with the help of this array and this system. The system that I mentioned for you, we call it eNose or electronic nose. Electronic nose, which widely nowadays used in different places, and maybe you don't know, but in all the airports nowadays, they are using eNose system. Even in the food industry, it has the vast application when they want to see the quality of the food, quality of the air, quality of the different product. For example, um, when they want to check the quality of the alcohol or even wine or any drink, they are nowadays they are using eNOS, or as I tell you, in the airport, when you take your luggage to the security section. In the security section, there is the eNose chamber, which can detect and smell from your luggage. If they understand that something irregular there, then they will tell you to open the luggage and so on. Then this meaning of eNose, it's become more popular these years because it shows the good performance. And as I tell you, this is one of the points which is going to help the human smell sense. And it's going to replicate the human nose, and also help it to improve that. If you have a look to this picture, here I compare the human nose and also the artificial nose, which we call it eNose together. In the human nose, we have one part that we call it receptor. These receptors are equal to the sensor array, which they can be 1, 2, 3, 4, 5, 6, as much as you can have that receptor part. Then after that, we have one part inside our nose, which we call it olfactory bulb, which with the help of your in-halt and ex-halt, these bulbs can be refreshed and can sense. Remember this point because later I use this trick to help my system have the better olfactory system. This in-halt and ex-halt which you have in your body help your receptor to work better and become refreshed and get the gas better. You know that when, for example, there is the wind, you can smell better from the environment that you enter. These olfactory bulbs are equal to the pre-processing and database part, which we can have inside our eNose. And then from the brain olfactory cortex, which we have in the human, there is the part that in our brain, it should now classify and make the distinguish between the different odor and different smell. It can be replicate with the pattern recognition part. And then if you will see the whole flow from the odor which I have, it can be any odor. First, I have some interaction which my receptor or sensor can sense it, and we can generate the signal. Then this signal should process, and then we have the identification system. And finally, for example, I can say, okay, that was methanol, that was ethanol, that was CH4, methane, ethane, and so on. Then in whole, you will see here, eNose is nothing by replicant the human nose and with the available tools which we have. And you should know that nowadays we have more problem for these sensors part, which later we will talk more about. The use of Enos is not something that happened nowadays or is that this year or last year. It's come from very late time, I can say from the 1920. And even till today, we are going to develop it day by day. For example, in 1920, firstly, they introduced about the olfactory system of the human. And they proposed that we can have it in the electronic form. Then in 1960, the first reported Enos come to picture, and the use of that in 1961. Then you will see that for 20 years, we didn't have much more things because we didn't have the good classifier and classification algorithm. Maybe we have one famous algorithm for classification, which we call it PCM. Then you will see that around 10 years, after 10 years, again, we come up with the concept of the Enos, but it's come in one conference, and the word of the Enos established, means that people believe it in 1919. And then after that, different people start to use it and build the different Enos for different application till today. But still, you will see that we are working on the Enos and wants to have the precise one. One of the main problems of these Enos is the sensor part, which we have. Let us have a look more deep about the structure of these Enos. We say that when we have any aroma or any odor, first of all, we should extract the odor from that. Then before this sensor array, we need some method to push the molecule and spread them in the air. Okay. This is one of the important stage, which we call it aroma extraction system. And then after this sensor array part, we need some part that we should do the sampling, reprocessing, feature extraction, and then pattern recognition for us. This part, we call it, from the conversion to the digital to the pattern recognition, we know it as the computing platform part. And let us see inside of each box more, because later we will use the sampling method can be in different way. Okay. One of the famous one which people are used is the static headscape one and air content, which they are going to inject the air from one part to the chamber, which they have the odor, and then from other side, this air will push the molecule out through the sensor sides. There are some feature for any of these sampling method that I tell you. I will not going much more inside of them because it will take more time. But roughly, if we want to say, for example, adsorption method, which is very accurate, but it will take more time for us, then you can imagine for the security job, maybe it will not be very good things because it will take long time for us. A static head one, it's easy, but the accuracy is low. Then again, for the security job, maybe we have some problem. Dynamic uniform one, it can collection result relatively stable and reliable, but sample quality should be high, and air chamber also needs fixed time to remove the odor because the chamber that you have the odor should purge. Air contact one is easy to operate, but we have the accuracy problem. And also thermal method, which no need to solvent and it's automated one. But again, it will take time. Then you will see that for making the Enos, we have initial problem, which is that how I can extract my odor and introduce it to my sensor part. The next block is the sensor. For sensor, we have lots of good development, but all this development have one problem. One is that repeatability of the sensor is not good. We have problem for that. Response time of sensor is one of the famous problem which we have. energy consumption, and sensitivity to the amount of the odor is another one. Okay, along with all these, we have some more problem for our sensor. Means that they have the drift in the output, they have the selectivity, which is less, and environmental effects, something like temperature and humidity, which push the signal of our sensors to don't have the proper response. As I tell you, we have the good and development in the sensor, even still is not enough. We have different type of the gas sensors: optical ones, surface acoustic wave, electrochemical one, catalytic one, semiconductor one. These are the different type of the gas sensors. But in the INOs, you will see here the different type of the gas sensors. There is one problem that because you should change your sensors, and also due to the cost, due to the availability, due to the repeatability of the sensor part, people are prefer to use one type of sensor that they call it metal oxide one. Then this metal oxide one, or MOX type, which they are, we can say, the good one between all. Also, they are impact of the temperature and humidity and gas density. Means that again also we have the problem for the best type of the gas sensor. You will see that here. We analyzed two problems. One was how I can push my odor. Another one is that how I can sense it with my sensor. Here I bring the list of the MOX sensors, that the famous list of them. You will see that some of them are sensitive to one and more. For example, MQ2 is sensitive to the methane one, to the butane, LPG, and smoke. But you will see that the density of my gas, which we will show it in the form of ppm, is different. Suppose for methane, it has the 0 to 100 ppm. For butane, it has 0 to 5,000, and so on. But between this MQ type and TGS pipe, which TGS is the better one, we have some number which really they are the ideal number. Means that in the real world and real condition, we cannot sense from 0 to 100 ppm. Hardly we can start from 20, 25, and at the top we can sense up to 80 or 85 ppm for MQ2. Same scenario is for the TGS sensor. Even they are the best sensors which we can use for any gas detection, but we will see the sensitivity of them are not much more good, and also the density of the gas domain and range is not very high. The next part after the sensor is sampling system and AD conversion, which we can do it with any controller, any microcontroller, microprocessor. We don't have problem nowadays for this part. Next is data processing, that we can do it very nicely. Now we have lots of good reprocessing, feature extraction method, and prediction and classification and decision making. Even deep learning nowadays we have. This green box can do very nicely. Even the pattern recognition machine can be very nicely. But as I tell you, for the aroma extraction and array sensor, we have the main problem here. Previously, even there are some reports for the feature extraction methods that people use. For example, they use SVM, they use ML algorithm, they use the PCA as the very old classifier, or even artificial neural network. All of them are used and they show the good performance. But remember, the main problem that again we have this regarding the source of the data, that how we can extract the data, how we can sense the data. This is something that still all people are working on that and know it as the challenge for the INOs or entrance gate for the other localization system. Here I compare the PCA, ANN, LDA, and SVM, which later you can read from my paper. So on, to solve this problem and having the good signal from my other source, people will introduce the different algorithm. Okay. Suppose one of the good algorithm, which here we have, is something like this, that we can first have the building chamber, and then put the INOs in front of that, take the smell, record the data sampling, and then do the feature extraction. And then if the data was okay, then we should purge the chamber which we have, do the sampling, do the clustering, and then we can go for the detection of the gas. This can be the overall algorithm of any nodes, but uh, still, as I tell you, due to the problem for the sensors, one. Second is that the nature of the gas that we have, using the INOS itself, it will not be the good solution. We need some more things to add to our INOS and sensor system, which I will tell you later. Just to review about the INOS application, along with the other localization system, we can use it for safety industry, agriculture industry, indoor and air quality, medical and life science, aerospace, transportation, fire supervision, also industrial application, and so on. Even if you remember in the time of the corona, there was some use of the INOs that they could smell the um, uh, human breaths, and then they will classify that this person have the corona or don't have the corona. This is something that proved, and that was one of the successful scenario for the INOs. It means that the application of that is very vast. Okay, so on, then maybe you think that making the INOs is very difficult because we don't know what to do, but I want to show you, no, it's very simple. This is my first INOs that I make it in the year, yes, 2011. I made this first sensor. You will see that here I had some 3 sensor of the TGS, and then I have some signal conditioning, and I use the NI DAC card to save my sensor data. Then I had one GUI, which in that I could record the response of my sensor. Let me show you what I could record, because later we will talk about this response. This clip is available from long back on the YouTube, even you can check uh, about the sensor response and how to make the INOs. So many people saw that and they enjoy how I make the INOs with very simple things. You will see here, I have some response. And from here, this part, when the gas introduced to my sensors, the ramp will start to come up. And when I purge it, then the amount of the gas will be reduced, and then I don't have the response for my sensor. See, this is the initial stage for sensing my sensor. After that, I should have some classifiers, some pattern recognition method, which tell me that this signature of gas is related to which gas. It means that I should sample different gas, so many number of the gas. I should sample with different condition, different temperature, different humidity, and then have and compare the signal of my gas with the help of classifier and pattern recognition works. Okay, here, for example, you will see that I start the purge, and then my sensors show that it's gone. Here, just for your reference, I show you the shape and pattern of the different. For example, if I have the air and fan, I don't have much more things here for my sensor. You will see that the methanol, you will have the ethanol, you will have the butanol, you will see that they have the different signature or different shape with different sensor that I have. Suppose I have MQ2, MQ3, MQ7, MQ5, and MQ6 sensor. And here I show you the pattern and shape of my sensor response. Okay, then the next INOs that I make, that was with the help of this system. You will see that they are prototype. That is why they are not very nice. And what we have done here, we start to purge also the amount of the gas into the INOs to have the better result. And we could get the good result from our sensor, means that the same shape we could get through the GUI that we design, and it could give us the different signature for the different gas. The latest one before latest, because last year also we worked on the INOs here in China, and that's contain around 20 sensors that INOs. This is one before that, which I use the Arduino board because I thought that the NILVC is expensive. And then I use the MATLAB GUI part to take the data and analyze the data. And if you will see, I have the INOS part here, sampler, and also data acquisition part, which can be in one computer. It means that we can design the INOS very nicely, and we don't have problem for that one. Classification and all can be done, but still we have the problem for the response of this sensor. Remember, INOS for us is the part which is not now moved. It's fixed. Later, if we want to use this array of sensors on tracking anything, we should move it. Then the second problem or third problem for the sensor will come to picture, that any movement can change the shape and signature of my sensor. Okay, this is again that latest one, and this is the sampler part, which we will put the order here, and then we can, with the help of the aquarium pump, we can push the molecule inside the INOS, then INOS can sense it, and then I can log the data, and then after that I can classify and translate this data for myself. Now, the second and important things will come to our mind. Okay, if INOS is that much simple, then okay, Plume tracking and other tracking job is nothing. No, let us first know the difference between the Plume tracking and other tracking. Plume tracking, we know it as the process to following the concentration gradient of the other molecule. And in that, we will give the ability to analyze the distribution of the other molecule. And it can be in different use, something like gas leakage, something like searching for chemical sourcing, hazardous environment, and guiding the autonomous vehicles for us. Other tracking is referred to the broader process, because just not we are going to track, we should go to the direction of the gas, and also we should do the localization job. Means that other tracking is one step ahead from the Plume tracking robots, and if you can do the other tracking, you can do the Plume tracking job also. Then the application of that, it can be for environmental monitoring, for the rescue operation. For example, if they want to find the body in the avalanche or in the earthquake, they can use these other tracking robots by sensing the rate of the O2, and they can find out that that person behind the um, avalanche or be in the earthquake situation, is live or is dead. Like this, you will see that these two jobs are become very demand between the researcher, and they are going to use it in different stage. The stage for the odor tracking can be in three parts. One can be odor detection, which we will detect Second can be source tracing, which can be follow the cues, and source declaration, which is going and say that, okay, source is here. And then for the plume tracking, it will come to detecting and increase concentration of the gas. It can follow the odor and just go and follow the movement of odor. Maybe you will see the smoke. A smoke is one of the good hint and example which can show you how smell are moving. You will see that it can start from one nozzle like this, but the movement can be different, which really working with this is not much more easy. And finally, we have the source declaration, which robots, for example, here should come and reach the nozzle part, which we have. This plume tracking, as I tell you, it's used in the nature very nicely. And this application, which, for example, for the moths we have, for the beetle we have, inspired the researcher to investigate the algorithm that they have. For example, they work more on the beetles and also work more on the moths, that how they will work, how they will do. And even they work with the bacteria and find that they are doing some random movement to take the signal and then follow the signal till lost it. Then again, they will do the random move and do that. This job, they call it chemotaxi and anemotaxi. Chemotaxi, we know it, the mechanism which is based on the concentration gradient of the odor or chemicals in the environment. And the organs or the robots which we have should move in response to the chemotaxis and varying concentration of it. The other words that we have, this is anemotaxi, which anemotaxi involve the movement which influenced by the airflow and observation. This mechanism will be observed in the robots that navigate by detecting and responding to the air currents. Means that the idea for the anemotaxi is that, as we know, air is carrying the odor. Then instead of just relying on the odor, we can trust on the direction and sensing the air and track the air. If you track the air and also odor both together, in the time that you lost the odor, you can track the air. And then most probably you can reach the source of the odor. Another taxi which we have, this is infotaxi, which is describe the movement based on probability and information theory. Means that suppose we have some idea about the movement of the gas in the chamber or in the room, and then we are following that mathematical and movement strategy, and then we can reach the source. As I tell you, in the nature, silk worth moths or Bombay Mori, this is one of the best example that they can do the plume tracking. They have 20,000 olfactory hair on which they can make the pheromone, and then they can find the mate. How they will do, when scientists studied that, they saw that they are going with the direction of the wind, and then they can always move up the upwind direction, and then they do some zigzag movement, and when they will cut, then again they will track the order. When the order is cut, then they can again move on with the zigzag movement, something like this. This is the algorithm of the modes that they will start from here. They just do some random movement. When they will sense the order, they will follow it. And then again, they will do the zigzag movement for them. So on, they found that some of them will do like this, that they will start to make a spiral. And then after this spiral, sense the signal, follow the signal, and then when they lost it, again, they will do the spiral one that they call it casting. With this casting, again, they can sense the order and then follow the order till lost the signal, and then again they can go and follow the order for us. This job they call it casting. Then if we think for the random movement and think for the I mean zigzag movement as the random movement, or casting as that spiral one, we may think that if we want to do the plume tracking job, just one robot cannot be the good idea. I can have different or means that more than one robots that they are going to through the source, and then when they can, one of them, for example, can sense the signal more than other, it can inform and send the signal to others, then they can come and accumulate in one place and then follow. Then again, if another one find the more concentration of the gas, it can go and find. Then by these, which we know them as the bio-inspired algorithm, swarm intelligence with the help of PSO and ant colony optimization nowadays use more, and it shows some good result for these for this plume tracking job. Just very roughly, if we want to talk for the PSO and for the ACO, especially for PSO, which is, I can say, one of the successive progress for the plume tracking, we are always try to act like this. We always have one space, which we call it G base, and P base as the speed of my another robots, and it can be the source which we have. Then you will see that more robots or more birds now they are going through the source, and then the one which is nearest can send the signal to other to follow them. About this PSO, you can read more in the papers. I tell you about the info taxis. Info taxis working based on the probability and mathematical form. But mainly for the plume, we have one form that we call it Gaussian point source plume, which it has one mathematical equation like this. And people are using it in different applications. Suppose for pollution, they are using that, or for other distribution also. I saw that so many people are use this model, but this model have some limitation, you know, that mainly it's for the chamber that you don't have the wind, and gas will come from one specific location from your room, and then they spread very nicely in whole room or chamber, and then can be purged. Like the sensor response, which we had before. Then, as you will see, it can be one of the hint for the info taxis. Even I work with this equation with the help of the wind. This is my simulation result. The result was not bad, but again, for the real application, the model that was not very good, we can say. Performance. So on this model, they call it diffusion of the point source pollution. It's very famous, work in very, what we can say, in so many areas it's working. But unfortunately for the job, which we are seeking for them, this is Plume simulation part that was not very good. Okay, let me give you one overview about that, how plume are movement. You will see that in the diffusion, we expected that they are going very straight, is that the formula will tell me something like that. But if you will see the real shape is something like that, meandering. Always it will go up and down, up and down. Then my robots cannot detect very nicely if it just rely on the sensor's value, because as you will see, the concentration of the gas in this plume are different. This dark circle will shows the more concentration, and the lighter one will show the less concentration. Then when the odor or plume is moving, it has the different variation of the concentration. That is why I said that tracking the plume is not simple job, and still this is one of the challenge which we have. Okay, we talk about the challenge which we have, the shape of the odor, and we talk about the enos and sensor part. But let us see what people have done till today. I will go very fast about this part because there is two reasons. Reason number one is the time which we have. I don't want to spend more than a specific time. Second thing is that uh, really some of these robots that they are using now, they are not valid. But as the survey, we should review them. If you see the history of the odor localization, you will see that first it will come with the early observation from the
Oh,
human
Fasad.
and
Oh,
animals.
Zakaria Ganduke.
And from the human and animal have the long relied on the sense of the smell. For example, for the food, for the avoid danger and navigate through the environment. The second step, which started from century 70 and 90, the scientific study of the olfaction will begin to take the shape with the researcher like John, which is making the early observation about the olfactory system. In the 20th century, we have some significant discover about the natural uh, shape of the odor localization. Then from the early 20th century, we find some animal behavior and study, and we try to replicate them. Then engineering and robots are come from 1990, which especially for the ant bot, which Thomas make that robots as the pioneer job to do the odor localization job. And then next was the biological insight, which all of the people are attracted with the creature because there was two reasons. Reason number one is that insect, they have the binary form of the brain, then they are not very powerful CPU. And just by comparing yes, no, or 0101, they can track the odor very nicely. And that was one of the main reasons. And also the size of the creature was one of the issue that you will see that one ant or I don't know, one beetle, the size is very small, but they can localize and track the odor very nicely. So on, recently now we are with the technological application that we are going to use them for the gas leak and so on. There are some robot platform, for example, in 1996, they made one gas sensor here, then they changed the height of the gas sensor. They use one DC fan to purge the chamber. Then they will suck the air here and then detect the gas, and then they could follow the gas. So on, they thought that instead of one semiconductor gas, they can have more than one. They can four, and then use it inside in the clean room of the 5 by 2 7 meter room, and then they could detect the gas with the help of the TGS gas sensors, and then follow the gradient of the gas. So on, even we have some hexanol and ethanol uh, odor, which people start to use with the help of the gas sensors and wind direction, both together. This is something that later I also use in my system. This is one of the part that we can trust on that. And one thing that I should tell you, for other localization with the robots, when they want to do the sampling job, instead of using the CH4 or H2S in especially indoor place, they will not use that gas. Mainly they are used the ethanol or any other gas which is not harmful for the people. But you should remember some ppm of the ethanol, more than 1,000, also is not good for the human, and it can affect the health of the. So on, they thought that instead of having 4 or 3, they can have the array, and then they can sense the sequence of the sensing of the odor means that it will come from 1 to 2 to 3, 4 to 5, something like that. And then they can detect and navigate the robots through the source. That is also one of the nice jobs which come with the help of the Russell in 2001. Then another robots that they just try to detect the wind, and they say that if we can find the source of the wind, then we can find the source of the odor. By the Koala platform, they could go and find the source there. So on, we had some method that we call it reverse detection. They put one sensor at the first and one at the end, and any of them which can sense the higher concentration, the robots will rotate. That was not the bad idea, but this movement also can kill the molecule of the gas, and I don't advise it for a later job. So on, there was one more platform by the Lino, which he also used the fan to purge and also detect the gas sensors. And then people come to see that where they should be the proper place for the sensor, what should be the shape of array of the sensor. Some people say that, okay, 4 sensor is okay, and then they put it like this. When the C and F, both of them can sense the odor, then it means that you are exactly in the direction of the odor. Then you can go straight. Otherwise, when you are in the left side, it means that the concentration is more. When the right side is more, it means that the odor in the right side of the odor, then robots should move. From this, I take the good idea and I use it in my system, which I will show you, but I extend the array later. So on, there are more and more applications that people start to use and localize with the help of the different platforms. But one thing was remained. If you remember for the Inos, I told you that we have the sampling problem. We should extract the aroma. We should extract the odor for ourselves. One of the nice job which happened by the Achim Blitra in 2004 was that he put the sensors at the end of the pipe and also put one fan at the initial gate of the pipe. Then it could suck the air, and then when it can suck the air faster, it could improve the speed of the gas sensor. This idea was nice. I extend this idea later in my system. Even there are some problem with the idea that Achim used, because he continuously turned on the fan, and by this method, it killed the molecule of the gas, which that was not good. So on, we had different methods. Even some people like Ishida, he thought that instead of gas sensor, we should merge it with the camera and use with the thought and detect the source. Or there was even some idea of the ball, which in that this is just one idea. They didn't implement it. They thought that to have the faster movement, the robot should be in the form of the ball or the balloon, and then they can detect it with one help of the gas sensor. You will see here people use the different shape, different sensors, different type, and different strategy to localize the gas sensor. They change the height, but still the speed of the detection and localization was not good. Even some people like matter, he put some obstacle between the movement of the robots and source of the robots, and then he could localize, but all of them was inside the indoor room or inside the very small chamber. For the outside, there was not much more record. This is also one of the platform that Botra have done. He was from our lab, and he used it with the very nice platform, I can say. But the problem was that this platform need the concentration more than one number. For example, more than 100 ppm it could detect. Then it was not the plume tracking or other localization. It just sense the gas and go through that part, through that robot part. There are again different methods. Even recently, they start to use the vision as well as gas sensors through the Arthur motor. It's based on the some ready-made event platform, and by that they could localize the odor in the outside. But again, that was not very good and high localization part. Okay, till now, we learned about some point. Point number one was that we need the array of sensors. Okay, we will use the INOs. Second thing is that we need some sampling or pushing the molecular method. Okay, we use one fan. We use some classification and recognition method, pattern recognition method. Okay, we are use different methods. But still, we are not successful. What we should do? This is my job, means that the other localization and plume tracker robots that I made it with the, especially I made it with the big size. Later, I could make it with the small size. And we publish some paper based on that you can later follow that. Before that, I should tell you about the other shape. As you see from my INOs, we had some part from my gas sensor that I will introduce my other molecule for my sensors. And from this point, the sensor can sense the gas. And when the molecule will run or purge, then we have the rising slope for the graph which we have. In my test, I make inside my lab one chamber. And instead of first using the movable robots or movable sensors, I put my INOs inside one pipe. And first, try to find the best method that I can suck the air. What I found, actually, there is one scenario. After I studied the sniffing method of the dog, I understand that they are sniffing with the frequency of 10 hertz. And in-halt and ex-halt for the human or for the creature is the one point that can help our olfactory system or olfactory bulb to become refreshed. I thought that, okay, we can do the same job for the sensors. I can put one fan at the initial gate of my pipe and sensor part, another fan at the end. Then I will do the in-halt and ex-halt method. Means that I will suck the air, then I will purge it very fast. But when I will suck the air for my chamber, inside my chamber, my sensor can detect the gas and then can analyze, send to the CPU, take the signal, find the direction, and then go for the next level. Like this, I could improve the performance of the gas sensors much more. And even I will go a little bit fast for this part. We have one protocol that we will inject the odor for 20 seconds. Then front second was 8 seconds. Off time was 26, means that nothing will happen in 26 seconds. And after 8 seconds, I could purge my signal. You will see here how I do with fan 1, fan 2, and how they can help us. The aim for fan 1 was that increase this slope for me. And fan 2 was that increase the decreasing slope for myself faster. After doing all, we had very good results, and we understand that we can get the signal from the sensors, from the odor, 60 centimeter ahead from my sensor. It means that from 60 centimeter, I can have some signal, which it's not affordable with just one fan, and it could improve the movement of that. This result we published in 2000, I think 14 in the journals, and it's published now. For the next part, I found that one sensor will not be helpful. Then instead of one sensor, I use 7 gas sensor for my robots with the fan in front and one at the end. And Inos was inside each part, 2 sensor, as you will see here, as ahead, and other one will come with the shape of the W. How we shape with the shape of the W? Because we understand that if S1 can sense the sensor, it means that, okay, I am exactly in front of my source. S1 from S2, S1 from S3, always compare. If right side was more, I should go through the right side. If left side was more, I should move through the left side. And S3 and S4 is for safety. We put it with some distance that if my odor or gas sensor has the distance to my robots, S5, if it's more, it means that the odor is in the S5. For the right side, I should move to the right side, and also for the S4. 2 more sensor I put with the height of 20 centimeter or 30 centimeter from my robots at the top, as you will see here. This one is when I have the distance to my plume, as I show you the formula, based on the Gaussian process, this odor will take the height. These are some which can increase the chance of the height. Then, as you remember, I told you that with the help of the direction of the wind, we can detect better the direction of the odor. Then I made 3 wind detection sensors. These are my invention that we put here. This is another paper you can read later, which based on the detecting of the wind direction, you can do it. Why we invent this direction, these wind sensors? Because the size of the wind sensor are generally very big, and also that time they were very expensive. Then I made them based on the thermal criteria, and we find that each part which have the less temperature, it means that we have the wind there, okay? And then we can sense. The combination of all these things that I tell you, one is that infotaxis about the gas Gaussian process. One is that about the behavior of the sniffing of the dog and mouse. Next is that with the wind direction, which most will follow, all of them we put inside my robots, and this platform we call it Mukhtar. Also, it has the camera, it has some GUI that you can log the data, and you can compare the data. To test my robot, I select 2 areas now. One was inside the chamber of 260 centimeter by 168. There was the plastic chamber that we will see later, the movement of robots. And we put the nozzle in 3 different places, S1, S2, S3, with the 84 centimeter distance. And then we inject the alcohol inside the chamber. My robot will start from 3 different locations of L1, L2, L3, and go to localize the gas. That was the scenario 1. Scenario 2 was with the 300 and 700 meter distance through my source, and then again we put it with the L1, L2, L3 different location of the sensors, but that was outdoor test, okay? That we use it with the 3-meter and 7-meter distance through the robot location in the corridor of our school, and we start to test. Okay, here you will see my chamber that I also use 3 fan, 2 at the top and 1 at the end, to purge and clean the chamber. And then here, suppose you can see the movement of my robot. Let me go fast. The other, for example, that was in these sides. This is the nozzle part, which you will see that the robots start to move and go through that source. And sometimes, let me go a little bit fast because later you will see. Sometimes what will happen, the robot will lose the signal. Then when it will lose the signal, it will start to do the spiraling job, okay? That was the indoor experiment that we have done for our robots. And then even sometimes as the odor will come to the other side, means that the concentration become more in the other side of the chamber, robots will rotate and come back to the initial place which we have. So on, we increase the movement of our robots and tested in different location. One was that for the 3 mm, and this is the source of my gas in the corridor of the school, and you will see even I can move, but it can go and localize the source with different location of L1, L2, L3. And later, what we have done, we changed the nozzle between 0 to 180. This is me, as you will see, which we tested from the other side of the corridor to this side because we had one place that generally they have the wind there. And that was the good place for us to test the algorithm. Then the algorithm shows the good performance of localizing the robot. Even we have some good result up to 12 meter from the source, which robots could go there. But because the rate was below 90, and we just reported the 100 unsuccessful rate, we didn't report that in our job, but that was available. See here, this is the signal that each sensors for me, based on the array, can get and get it. And also, sometimes if you will see that we have some noise like this, it shows that some person move around the source. And you will see here, when the robot passes the source, the signal will come down and it cannot detect. It means that the movement was not random. Again, as I tell you, we changed the direction of the source between 0 to 180, and then we test it. The result you can get from this paper, which it shows the performance and development of the robots. Okay, as the conclusion, I can tell you some points that this job of odor localization, odor tracking, plume tracking, and other have the nice application. In the research area, most of the people are doing the odor localization. Odor tracking and plume tracking have the second step or second level for working. Mainly, if you want to know which odor people are doing in their research, mainly people use ethanol because they are thinking about the environment that they want to work and the person who want to take the sample. Rarely they will take methane. And also you should remember the molecula for the ethanol are much more lighter than the methane and other, means that if you can reach the ethanol molecula, then definitely you can meet the methane molecula later. From the strategy point of view, people mainly try to use the biological, some approach like me, they try to mix the different algorithms. And, but even there are some cases that 80% of people use the gradient-based method. From the type of the sensors, mainly people made their INOs with the help of TGS sensors. Then with respect to the robots that people use, 21% of the people try to make their own robots, and they are not using the ready-made platform due to the mainly the modification that maybe later they should do. This analysis is common. Even there are some rate for the Koala, Kepera, and Super Scott platform, but still people try to make their own robots as the job that I have done, because later they are free to do the change for them. There are some history or some work and comparison between the people who have done the other localization and Plume